Welcome to What the F Happened, Fraud and Financial Crime Deconstructed, a Defend podcast where we break down what's actually happening across fraud, scams, AML, and financial crime.
Each episode cuts through the noise to explain the tactics, trends, and real-world impact behind the headlines, so you're better prepared for what comes next. Let's get into it.
So we're looking at a stack of reports today that, well, they paint a pretty tense picture of the financial world right now.
A very tense picture.
You have these massive institutions, we're talking banks, fintechs, and they're caught in what really looks like a paradox. They're under this, immense pressure to stop fraud and money laundering.
It's the classic arms race. The criminals get smarter, so the defenses have to get smarter.
Right, so they're deploying the most powerful AI they can get their hands on. But here's the friction point.
Yes.
The regulators are looking at these new hyper-intelligent systems, and they're basically saying, hold on.
We don't trust this.
Exactly. We're seeing this major pivot where accuracy, just catching the bad guy, it's no longer the only metric that matters.
It's arguably not even the most important one anymore. If you look at the recent regulatory inquiries, the ones in the source material, the issue isn't that banks are missing fraud.
I know.
It's that they can't explain how they found it.
That is the black box problem, and that's our mission for this deep dive. We're going to unpack why the industry is being forced to move from simply using AI to needing explainable AI. We need to figure out why a system that works perfectly might still be, well, illegal, and break down the specific checklist that turns a black box into something you can actually defend.
It really all comes down to accountability. We're moving from an era where it was enough to just get the right answer to an era where you have to show your work.
And in high-stakes finance.
Showing your work is the difference between a compliant bank and a massive fine.
So let's start with the technology itself, because the sources describe this evolution that really created the problem in the first place. We didn't always have black boxes.
No, not at all. For decades, fraud detection was rules-based. It was very linear logic.
Like a flowchart. If A happens, then do B.
Exactly. If a customer wires more than $10,000 internationally at 3 a.m., flag it. It was rigid, sure, but it was transparent.
You could see the logic.
Absolutely. Our regulator asks, why did you freeze this account? You could point to line 40 of the code and say, because they violated Rule 12.
But the problem with those simple rules is that they're brittle. The criminals just figured them out.
Of course.
They started structuring transactions doing, what, $9,900 instead of $10,000? This is smurfing, right?
Right. And that's why the industry pivoted to machine learning and eventually deep learning. These systems don't just follow hard-coded rules.
No, they learn.
They digest massive data sets, transaction history, device fingerprints, mouse movements, IP addresses, and they learn patterns on their own.
And this is where the black box idea really comes in. Because when one of these deep learning models flags something, it isn't following a simple if this, then that rule.
It's exponentially more complex. The model might be looking at 1,000 different variables at the same time. It might see that a user is typing 10% faster than usual, coming from a new IP address, and transacting with someone who has a slightly higher risk score. No human wrote a rule for that specific combination.
The AI just learned it.
It just learned that this specific cluster of variables equals, say, a 99% probability of fraud.
So the output is accurate. The system says fraud. But if you ask the system why,
it can't give you a human-readable reason. It can give you the math, the vector weights inside the neural network. But for a long time, the attitude in tech was, who cares?
I can hear the engineers listening right now making that exact argument.
Right.
If the model stops terrorist financing or catches the credit card thief, isn't that the goal? Why does the explanation matter if the outcome is good?
And that's the utilitarian argument. But the source material is very clear. In a regulated industry, the how matters just as much as the what, which brings us to the concept of adverse action.
Okay, this is the legal side of things.
Exactly. When a bank freezes an account or denies a transaction, they are taking an adverse action against you. In the U.S., and under rules like GDPR in Europe, that customer has rights. If you freeze someone's money and they ask why, you cannot legally just say,
the computer said you look suspicious.
You can't. That sounds like a dystopian nightmare.
Computer says no.
It's a nightmare for the consumer, but it's a liability nightmare for the bank. If you can't explain the decision, you can't defend it. Imagine trying to explain that to a judge.
Your Honor, we don't know why we flag him, but our model is usually right.
You'd get laughed out of court. And then there's the other big issue, bias.
Ah, right. The risk of the model finding proxies for protected attributes.
This is where the black box becomes a compliance minefield. Let's say you feed the model 10 years of historical data to train it.
Okay.
If that historical data contains biases, say certain zip codes were historically flagged more often, the model learns that pattern.
So it effectively learns to redline, but without anyone explicitly telling it to.
Precisely. It might flag transactions from a certain neighborhood as high risk just because of the zip code, not because of what's actually happening.
And with a black box, you wouldn't even know it's doing that. You just see the high-risk label.
But if a regulator audits you and finds you're disproportionately flagging a specific demographic, you're in deep trouble. Fair lending laws, non-discrimination statutes.
And saying, we didn't know, is not a defense.
Ignorance is not a valid legal strategy.
Uh.
You have a duty to know, which is why the sources are so heavy on this concept of auditable logic.
This leads us to a really important distinction made in the reading. I think a lot of people, myself included, tend to use the words transparency and explainability almost as synonyms.
They're not.
But the research draws a very hard line between them.
It's the most critical distinction in this entire discussion. And honestly, it's where a lot of vendors, they try to pull the wool over buyers' eyes.
So let's break it down. What does transparency actually mean in this context?
Okay, think of transparency as the glass box.
A glass box. Oh.
It gives you a view of the system's architecture. It answers the question, how is this built? So transparency means you have documentation on the data inputs, the model version, how often it's updated, maybe a dashboard with performance metrics.
So I can see the machine, I can see the gears turning.
You can see that the gears are turning, but, and this is the key, transparency doesn't tell you why the gears turned a specific way for a specific case.
Okay, so that brings us to explainability.
And explainability is the why. It's granular. It answers the question, why was this specific transaction flagged?
The source used a medical analogy that I thought was really helpful here.
The open surgery concept.
Right.
So transparency is like watching a surgery through a glass wall. You see the doctors, the tools, the patient. You know a surgery is happening.
That's transparency.
But unless you're a surgeon, you have no idea why the doctor just made that specific incision. Explainability is the doctor turning to you and saying, I am cutting here because the artery is blocked at this exact point.
That clarifies it perfectly. You can have a fully transparent system, great dashboards, even open source code that is completely unexplainable when it comes to one decision.
And that is the trap. A vendor will sell you transparency, look at our beautiful interface, and claim it solves the regulatory problem. But if an analyst clicks on an alert and can't understand the logic, that system is not explainable.
The regulators are catching on to this difference.
Oh, they are. The source lists the heavy hitters, the OCC, FinCEN, the FATF on a global scale. They're all issuing guidance that moves beyond just model governance. They're looking for defensibility.
They want to know that a human being can validate the machine's output.
Precisely. The concept is human-in-the-loop validation. If the human can't understand the machine, the loop is broken. The regulator doesn't want to talk to your algorithm.
They want to talk to your compliance officer.
And if your compliance officer can't explain the logic, you fail the audit. Simple as that.
So we've established the problem. The black box is a liability. We've established the goal, explainability. But what does that actually look like in practice? The source gives a checklist of 4 core features.
Yes.
I think we should walk through these because they're really practical.
This is essential. If you're a bank looking at vendors or a tech-led building this in-house, these are your non-negotiables.
Okay, requirement number 1, human-readable rules and annotations.
This sounds simple, but it is so often missing. When an alert fires, it needs to come with plain language, not a vector code, not a raw data dump.
No jargon.
It needs to say flagged because transaction velocity is 400% higher than the 30-day average.
It's a translation. It's taking the complex math and making it something an investigator can grasp in 5 seconds.
And it creates efficiency. If an analyst sees flagged for unusual location, and they can also see the customer bought a plane ticket yesterday, they can resolve that alert instantly.
Right, but if they just see high-risk score,
they have to dig through the whole profile. It empowers the human to make a judgment call.
Okay, requirement number 2, alert traceability.
This is the show your work feature. You have to be able to drill down from the alert all the way back to the source data. Which model triggered this? Which rule? What specific data point was the tipping point?
Like a breadcrumb trail for the decision.
Exactly. In a black box, that trail vanishes. In an explainable system, you can trace the entire decision path. This is crucial for root cause analysis.
So you can fix mistakes.
If your system makes a mistake, a false positive, you need to know why so you can fix the logic. You can't fix a black box. You can only retrain it and hope it learns better next time.
Requirement number 3, version control and audit logs. This feels like the boring part, but the source says it's critical for legal defense.
It is the time travel problem. Imagine you're being investigated today for a decision your bank made 2 years ago.
And your AI model has probably updated 50 times since then.
Right. The model you have today is not the model you had then. If you run the old data through today's model, you might get a different result.
I see.
So you need a system that logs the exact state of the logic at the moment of the decision. You have to be able to say, on February 17th, 2024, this was the logic we were using, and based on that logic, this decision was correct.
Without that log, you can't prove you were compliant back then.
And if you can't prove it, the regulator assumes you weren't.
And finally, number 4, configurable thresholds.
This is all about control. Every institution has a different risk appetite. A global bank's risk profile is totally different from a small regional credit union's.
You can't have a one-size-fits-all model.
No, the source emphasizes that you cannot just accept out-of-the-box settings. You need to be able to turn the dial yourself.
So if you're getting too many false positives,
And you're annoying good customers by freezing their cards, you need to dial back the sensitivity. Or maybe you're under regulatory scrutiny and need to tighten the net. If the vendor locks that logic away in their black box, you're not managing your own risk.
you've just outsourced it.
You've outsourced your risk management to a software company. And regulators explicitly say you cannot do that. You are responsible.
The source puts it so bluntly here. It says, without these 4 capabilities, readable rules, traceability, audit logs, and configurability, even the most accurate AI is indefensible.
Indefensible. It's a strong word, but it's the reality. If you can't defend the decision, the system is a liability no matter how much fraud it catches.
So for our listeners who are in the industry, maybe looking at buying one of these solutions, it's a big buyer beware warning here.
A huge one. The market is absolutely flooded with AI solutions right now. Everyone has an AI sticker on their laptop. It's the buzzword of the decade.
So how do you separate the real deal from the AI washing?
You have to ask the uncomfortable questions during the demo. When the vendor shows you the fancy dashboard, you have to ask, can I see the logic behind a specific alert?
And if they say, oh, well, that's our proprietary secret sauce.
Then you have a problem. Proprietary is often just code for black box. You have to ask, do I have control over the thresholds? Can I tune this myself? And most importantly, can I audit the decision logic from 2 years ago?
If the answer is no, or we're working on that, you walk away.
You have to. Because again, when the fine comes, it's written to the bank, not the software vendor.
It's interesting. We started this deep dive talking about tech neural networks, decision trees, but we're ending up talking about design philosophy. The source argues that explainability has to be built into the detection's life cycle. It can't just be an afterthought.
You can't take a black box and just tape an explanation to the outside. It doesn't work. The system has to be designed from the ground up to be interpretable. It's a fundamental shift in how we build these tools.
So we're not just building for accuracy anymore.
We're building for collaboration, a collaboration between human and machine.
That collaboration piece feels key. We hear so much about AI replacing humans, but in this context, it seems like the AI is almost useless without the human to validate it.
It needs the human for context, and it needs the human for accountability. The AI can crunch the numbers, but the human has to stand behind the final decision.
Okay, let's zoom out. We've covered the black box problem, the regulatory pressure, the checklist for compliance, but there's a broader takeaway here about the nature of protection.
This is what really stuck with me from the reading. We tend to think of protection in finance as just stopping the bad guys.
Right. Stopping the fraudster, stopping the money launderer, that's the operational goal.
But there's a second layer of protection, protecting the institution itself, from regulatory enforcement, from lawsuits, from reputational damage.
And an unexplainable AI might solve the first problem, but create the second one.
Exactly. If your AI stops the fraud but gets you fined $50 million for lack of model governance, it didn't protect you. It actually introduced a massive new risk.
So true protection means doing the job and being able to prove you did it correctly.
That's it. It's a powerful reframing. Clarity isn't just a nice-to-have feature anymore. It is a security feature.
Clarity is the foundation of trust.
And banking is built on trust.
So, to bring it all home, the days of move fast and break things really seem to be over in this sector.
The new motto is move fast, but bring a map.
Ah, I like that. Move fast, but bring a map. You need to know how you got there. For everyone listening, whether you're running a compliance team, building these models, or you're just a consumer wondering why your transaction got declined, think about that. Why? The next time you interact with an automated system, ask yourself, is this just transparent? Or is it actually explainable?
Because there is a very, very big difference.
Thanks for diving deep with us today. Check your systems, ask the hard questions, and we will catch you on the next one.
Goodbye, everyone.
You've been listening to What the F Happened? Fraud and Financial Crime Deconstructed, a Defend podcast by DataVisor. If you want to keep learning between episodes, check out Defend Training, a set of self-paced online courses for fraud and financial crime professionals, practical and built around real-world scenarios.
And you can earn CPE credits through the ACFE San Francisco Bay Area chapter. You can find it at datavisor.com/defendtraining. The link's in the description.
This episode's audio was generated using Google's Notebook LM, based on expert analysis and trusted sources. Thanks for listening. We'll see you next time.